The National Electrical Code, or NEC, mandates a minimum of 2 small appliance circuits in any apartment, irrespective of its square footage. This regulation aims to ensure sufficient power availability and prevent overloading of circuits, which could lead to safety hazards. Each small appliance circuit, as per the NEC, must not serve more than 12 outlets. This limitation is put in place to distribute the electrical load and reduce the risk of overheating and potential fires. Additionally, each small appliance circuit is limited to a maximum load of 1800 watts. This wattage limitation is crucial to prevent overloading the circuit and ensuring the safe operation of connected appliances. Now, given that an apartment has only 3 countertop plugs, it is highly probable that all 3 are connected to a single circuit. If this is the case, then in order to comply with the NEC requirements, it becomes necessary to install an additional small appliance circuit. This new circuit would provide the required redundancy and ensure that the electrical load is appropriately distributed. The NEC guidelines for small appliance circuits are primarily concerned with safety. Overloaded circuits are a significant cause of electrical fires. By requiring a minimum of 2 circuits and limiting the number of outlets and the wattage per circuit, the NEC aims to mitigate this risk. Meeting the NEC requirements for small appliance circuits is not just about compliance, it's about ensuring the safety of the occupants and the integrity of the electrical system. Firstly, compliance with the NEC is legally required in most jurisdictions. Failure to meet these codes can result in fines, penalties, and even legal action. Secondly, following the NEC guidelines ensures the safety of the building occupants. Properly installed and maintained electrical systems reduce the risk of electrical shock, fire, and other hazards. Thirdly, adherence to the NEC can improve the value and lifespan of the property. Electrical systems that are up to code are more reliable and less prone to problems, which can save on repair costs in the long run. Understanding the NEC requirements for small appliance circuits is essential for electricians, building contractors, and homeowners alike. By following these guidelines, everyone can contribute to creating safer and more efficient electrical systems. The NEC defines a small appliance circuit as a 20-amp circuit dedicated to serving receptacle outlets in the kitchen, pantry, dining area, and similar locations. These circuits are intended to power small appliances such as toasters, coffee makers, blenders, and other kitchen gadgets. While refrigerators and garbage disposals are typically on separate circuits, small appliance circuits are designed to handle the combined load of multiple small appliances. When planning the electrical layout of a kitchen or similar area, it's important to consider the potential load of the appliances that will be used. Overloading a small appliance circuit can trip the breaker, causing inconvenience and potentially damaging appliances. By providing multiple circuits and limiting the number of outlets per circuit, the NEC helps to prevent overloading and ensures that the electrical system can handle the demands of modern living. To determine if an existing electrical system meets the NEC requirements for small appliance circuits, it's necessary to inspect the wiring and the breaker panel. Firstly, check the breaker panel to see how many 20-amp breakers are dedicated to small appliance circuits. There should be at least 2. Secondly, trace the wiring from each breaker to the receptacle outlets in the kitchen and dining area. Ensure that each circuit serves no more than 12 outlets. Thirdly, use a circuit tester to verify that each outlet is properly wired and grounded. If any discrepancies are found, consult a qualified electrician to make the necessary corrections. When adding a new small appliance circuit to an existing electrical system, it's important to follow proper wiring practices. Firstly, turn off the power to the circuit at the breaker panel. Secondly, run a new 12/2 or 12/3 non-metallic sheath cable from the breaker panel to the location of the new receptacle outlets. Thirdly, connect the black wire to the breaker, the white wire to the neutral busbar, and the ground wire to the ground busbar. Fourthly, install new receptacle outlets and connect the wires according to the manufacturer's instructions. Fifthly, turn on the power to the circuit and test the outlets to ensure that they are working properly. When calculating the load on a small appliance circuit, it's important to consider the wattage of all the appliances that will be plugged into the outlets. The NEC requires that each small appliance circuit be capable of handling a load of at least 1800 watts. To calculate the total load on a circuit, simply add up the wattage of all the appliances that will be used simultaneously. If the total load exceeds 1800 watts, it's necessary to either reduce the number of appliances or add another circuit. The NEC provides specific guidelines for the types of receptacles that are allowed on small appliance circuits. Firstly, all receptacles must be rated for at least 15 amps. Secondly, all receptacles must be grounded. Thirdly, ground fault circuit interrupter, or GFCI, protection is required for receptacles located within 6 feet of a sink. GFCI protection helps to prevent electrical shock by detecting ground faults and immediately interrupting the circuit. When installing receptacles on a small appliance circuit, it's important to follow these guidelines to ensure safety and compliance with the NEC. In addition to the requirements for small appliance circuits, the NEC also has specific rules for the placement of receptacle outlets in kitchens and dining areas. Firstly, receptacle outlets must be installed within 2 feet of any countertop space that is 12 inches or wider. Secondly, no point along a countertop can be more than 4 feet from a receptacle outlet. Thirdly, an island or peninsula countertop that is 12 inches or wider must have at least one receptacle outlet. These requirements are designed to ensure that there are plenty of convenient places to plug in small appliances. The NEC also addresses the use of extension cords and power strips on small appliance circuits. Firstly, extension cords should only be used temporarily and should not be overloaded. Secondly, power strips should be equipped with a circuit breaker to protect against overloading. Thirdly, it's important to avoid daisy-chaining power strips together, as this can create a fire hazard. When using extension cords and power strips, it's important to follow these guidelines to ensure safety and prevent electrical problems. The NEC is constantly evolving to keep up with the latest technology and safety concerns. It is updated every 3 years to reflect changes in the electrical industry. Staying up to date on the latest NEC requirements is essential for electricians, building contractors, and homeowners who want to ensure that their electrical systems are safe and compliant. The NEC is a complex and comprehensive document, but it is an invaluable resource for anyone who works with electricity. By understanding and following the NEC guidelines, it's possible to create safe and efficient electrical systems that will serve for years to come. When dealing with electrical systems, it's always best to consult with a qualified electrician. The electricians have the training and experience to safely install, maintain, and repair electrical systems. They can also help ensure that electrical systems are up to code and meet all applicable safety regulations. Attempting to work on electrical systems without proper training can be dangerous and could lead to serious injury or even death. In summary, the NEC requires a minimum of 2 small appliance circuits in an apartment, regardless of its size. Each circuit must serve no more than 12 outlets and be limited to a maximum load of 1800 watts. If an apartment has only 3 countertop plugs, it's necessary to add another circuit to meet the NEC requirements. Following these guidelines ensures safety and compliance with electrical codes. Understanding these regulations helps to maintain a safe environment and prevent electrical hazards. The purpose of these regulations is to reduce the risks of fire and electrical shock, which are major concerns in residential settings. By implementing the NEC standards, electrical systems can handle the demands of modern appliances and prevent overloading. Furthermore, regular inspection and maintenance of electrical systems are essential to ensure they continue to meet safety standards. This includes checking for damaged wires, loose connections, and other potential hazards. Qualified electricians should conduct these inspections to identify and address any issues that could compromise safety. Ultimately, adherence to the NEC and regular maintenance are key to creating safe and efficient electrical systems in apartments and other residential buildings. These practices protect occupants and property from electrical dangers. The NEC-specific guidelines ensure that electrical systems are designed and installed to meet the demands of everyday use. Following these guidelines minimizes the risk of electrical problems and enhances overall safety. The use of GFCI outlets near sinks and other wet areas is another critical safety measure required by the NEC. GFCI outlets are designed to quickly cut off power in the event of a ground fault, preventing electrical shock. Regularly testing GFCI outlets is recommended to ensure they are functioning properly. Another important aspect of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. All electrical outlets and appliances should be properly grounded. Over time, electrical wiring can deteriorate, leading to potential hazards. Regular inspections can identify any signs of wear and tear, such as cracked insulation or corroded connections. Addressing these issues promptly can prevent more serious problems from developing. In addition to the NEC, local electrical codes may also have specific requirements. It is important to be familiar with both the national and local codes to ensure compliance. Local codes may address specific regional conditions or concerns. When making any electrical modifications or additions, it is always best to consult with a qualified electrician. Electricians can provide expert advice and ensure that all work is done safely and in compliance with the codes. They can also help to identify any potential hazards and recommend appropriate solutions. Investing in professional electrical services is a worthwhile investment in safety and peace of mind. The cost of hiring an electrician is small compared to the potential consequences of electrical accidents or fires. Electrical safety is a shared responsibility. Homeowners, tenants, and landlords all have a role to play in ensuring that electrical systems are safe and well maintained. By working together, we can create safer communities for everyone. In conclusion, the NEC requirement for at least 2 small appliance circuits in apartments is a critical safety measure. By understanding and following these guidelines, we can minimize the risk of electrical hazards and create safer living environments. Regular inspections, proper maintenance, and professional electrical services are all essential components of electrical safety. The NEC is not merely a set of rules, but a comprehensive framework for ensuring the safe and efficient use of electricity. Staying informed about the NEC and other electrical codes is crucial for anyone involved in the design, installation, or maintenance of electrical systems. Electricity is an essential part of modern life, but it must be treated with respect and caution. By following the principles of electrical safety, we can harness the power of electricity while minimizing the risks. Remember, electrical safety is not just a matter of compliance, it is a matter of life and death.